Hi guys, welcome to my 7.4 video for statistics. We're back to hypothesis testing, but this time we're just given a different situation. So this time it's hypothesis testing for proportions. So when we're dealing with proportions, you'll know when to use this one because in the problem, there's not going to be given any mean or standard deviation. So that's how you'll know it's for proportions. For this section, you will need your pink chart, this one, with the z-scores on the side. So go ahead and get that out so that you can follow along. For the section, it's just like before how we had our setup where we had to check our conditions, we stated our hypotheses, we figured out in the problem what was alpha, we find a test statistic, we have a critical value or a rejection region, and then we make our decision. Remember, the decision was the thing with like their 3 sentences. So it's going to be pretty much the same format here, just slightly different formulas, stuff like that. So for our conditions, this part's exactly the same. For random, we're looking for the problem to either say random sample or like your sample was randomly selected, something like that. Okay. For normal though, this is where it changes. In the past, it either had to say normally distributed in the problem or n was bigger than 30. When we're dealing with proportions, because we're not given a mean and we're not given a standard deviation, how you're going to check to see if it's normal is that n times p has to be greater than 5 and n times q has to be greater than 5. And hopefully you remember q is just 1 minus p, whatever the decimals are. Okay, so then moving on to our hypothesis. Remember, we had an HO and an HA. And because we're dealing with proportions and not means anymore, the symbol that we use will be P instead of that mu. And then we have whatever number is the claim in our problem. Remember, the number here has to be your population mean or population proportion. It can't be from a sample. And then we either had like equals, does not equal, or we had the greater than or equal to and the less than, and so on. All of those symbols that we used before that always went together. Okay, then we had alpha is whatever's given to us in the problem. The test statistic. So when we're dealing with proportions, we go back to using z-scores, which is kind of nice because that's what we were used to. So that's why we're using our pink chart over here, except mine's not pink. Okay, but our formula for it will look like this. Like that. Okay, so let's talk about some of these symbols here. This P with a little hat on top is read as P hat. This is our sample proportion. So that has to be the number that came from the sample. Regular P is your population proportion, whatever we used in HOHA. Okay. Then at the bottom, we have a big square root. And then on top, it's P times Q. So it's this P right here, the population proportion, multiplied by Q, divided by N. Remember, N is your sample size. So that's your test statistic. Then whatever we get from that, what we want to do is kind of like what we did with our TO in the last section that we did. So our critical value here is going to be written as ZO, and then we're shading our rejection region. So this all depends on what alpha is. So remember, the way that you're shading your normal curve is based off of your HA So if it does not equal to, you're shading both sides. If it's less than, you're shading to the left, and so on. So for this one, because I wrote a does not equal to originally, it's going to be shaded both sides. To find the ZO, these are the numbers we're looking for here. It's telling us like this is where we're starting our shading. So ZO is found by putting whatever alpha is on the sides over here. So that'll tell you this is what you're looking for in the middle of your chart. So this is kind of like using our z-score table backwards. Okay, I want to do examples with this. That way we can actually see how this is done and make sure we do it correctly. And then we wanted to see if it's shaded or not to tell whether we reject or fail to reject for our rejection region. And then our decision will sound like what we had in 7.3. Okay, so first example. A researcher claims that less than 40% of cell phone users use their phone for most of their online browsing. So we have a random sample of 100 adults, so we know that's N. 31% say that they use their phone for most of their online browsing. But this percent right here came from a sample of 100 adults. So that's how we know this is our sample proportion. So that's P hat. This 40% then is P because it didn't come from a sample. Okay, and then it also says random sample, so we know that it meets the random condition. So check. For normal, we have to check that N times P is greater than 5, and N times Q also has to be greater than 5. Both of them have to work in order for this problem to be done. So N in this problem was 100 times P was 40%, so 0.40 would give me 40. So this is greater than 5. Cool, we did it. And N times Q would just be 1 minus 0.40, which is 0.60. This gives me 60, and this is greater than 5. Check, check, did it. Okay, so this problem works. If these ever don't work, then that means you can't do this problem. And the whole problem you just say you can't do it. It's pretty exciting. All right, for our hypotheses here, HOHA. So it says that the claim is that less than 40%. So less than is supposed to be the symbol without the equal sign. So that means we're using that for our HA. And I'll change that 40% to 0.40, which means our HO has to be the opposite direction with the equal sign, and we use the same number. For alpha, they told us alpha is 0.01. Cool. All right, so let's find our test statistic. So we have P hat, which they told us was 0.31, minus our HOHA number, which was 0.40, all over 0.40 times 0.60 over N, which was 100. Okay, so doing that in the calculator, you should get negative 1.84. I'm using 2 decimal places here because, remember, I'm using this to compare it to my z-score in the table, and our table only uses 2 decimal places, so that's why we round to 2. Okay, for our critical value rejection region, we're looking for a ZO. So here, in this picture, my HA was a less than symbol, so that means I'm shading to the left. Shaded to the left, my alpha value was 0.01. So that means I need to figure out what z-score has 0.01 below it. Since it's shaded to the left, then I'm just going to look in my chart real quick. 0.01 looks like it's closest to this one right here, which is negative 2.33. Okay, so that means my ZO right here is negative 2.33. Okay. But the z-score that I got was negative 1.84. So, oops, don't forget right in the middle is always 0. Negative 1.84, we need to figure out, is it in the shaded region or is it not? So negative 1.84 is closer to 0 than it is to negative 2.33. So this ended up not getting shaded. Remember, if it's not shaded, then we fail to reject. Okay, so in our decision then, it's going to sound pretty much like how we had it before in 7.3, but our test statistic of negative 1.84 was less extreme than our rejection region. So that means we fail to reject HO. And that means we do not have evidence that HA is true. So we don't have evidence that less than 40% of cell phone users use their phone for most of their online browsing. I'm just going to put ... No, I feel like I don't have space to write it all out. Okay, but this is the part where we're just saying what we said in our HA, but in words. Okay, so that's pretty much our problem. I'm going to do one more example with you just in case, and then the rest of this is your classwork. So, for this next one, we have a researcher claims that 86% of college graduates say that their college degree has been a good investment. So right here, this number is not from a sample, so that's your regular population proportion, so regular P. Okay, in a random sample of 1,000 graduates, so here they told us N, 845 say that their college degree has been a good investment. So here they didn't give us a percent, but we can figure that out because they told us this many, the 845 out of the 1,000, is the percent in the sample that said their college degree was a good investment. So that means P hat is going to be 845 out of the 1,000, which gives us a decimal of 0.845. Okay, so that's our P hat. And then, cool. So we've identified everything in our problem. So now we just need to check for random and normal. So random, they did say a random sample right here. And for normal, remember we're checking N times P and N times Q. Both of them have to be greater than 5. So N here was 1,000. P was 0.86. That gives me 860, definitely greater than 5. Great. So now we just need to check N times Q. 1,000 times 1 minus 0.86 would be 0.14, which gives me 140, also greater than 5. Great, did it. Okay, so this problem works. We move on. HOHA. Okay, so it says the researcher claims that 86% of college graduates say their college degree has been a good investment. So I don't see anything about less than, greater than, or at least, or anything like that. So it looks like that is the number that they're claiming. So since that's going to be an equals 0.86, that has to go for HO because HO is always the one with the equal sign, which means our HA is that it's not going to be equal to 0.86. Okay, alpha in this problem was 0.10. And then let's find our test statistic. So z equals, we have p hat, which is the 0.845, minus p, which was 0.86, divided by the big square root. Okay, so after that, setting that up, you should get 1.37 for your z-score. Okay, then for our critical value rejection region. All right, for the shading of this, we started out with a does not equal, so that means we are shading both sides. And then, because alpha was 0.10, that means all of my shaded region has to add up to 0.10. But since I have two parts of it, I have to split that into two, so that means this part has to be 0.05, and this side also has to be 0.05 in order for them both to add up to equal 0.10. So every time you're shading, whatever alpha is, that's what your shaded region should be totaled. And then in the middle, we have 0. So we are looking for our ZO. And we always start on the left. On the left side here, we have the shaded region is 0.05 for what's to the left of that number. So we're looking for 0.05 in our chart. So looks like the closest one is right here, right in between these two. So remember, if it's equally far away from two different numbers, then we need to take both z-scores and find the average. So this one goes with negative 1.64, and this one goes with negative 1.65. So if we take negative 1.64 and negative 1.65 and we average them, you should get negative 1.645. Okay, so this side, since we have a negative, the two sides should be exactly the same number. So that means this side's going to be positive 1.645. So remember, every single time you shade both sides, it's going to be the same ZO, just one's positive, one's negative. And the negative is also always on the left side. Okay. Our test statistic, our z-score was negative 1.37. Negative 1.37, I need to figure out, is that in the shaded area or is it not in the shaded area? And we got a negative, so it'll be on the negative side. But I think negative 1.37 is still closer to 0. So that means we fail to reject again. So our decision will sound pretty much like what we had before. Our test statistic of negative 1.37 was less extreme than a rejection region. We failed to reject HO. We do not have evidence that, and then we say that that 86% of college graduates say that their college degree has been a good investment. And that's it. So the rest of this is your classwork. This gets uploaded onto Canvas. If you don't have a printer, it's okay. Just write all the problems on another sheet of paper. Might take you a little bit longer because it's more writing, but here we go. If you have a printer, feel free to print it out. Canvas also has the options for you to download the PDF and just write directly on it or type into it. I don't care how you do it. As long as everything gets done, you can upload that as well. Alrighty. Message me if you have any issues, questions. I have office hours from 8 to 11 a.m. every day. We can video chat on there and I can help you out with any problems. You got plenty of time to meet with me. Or just send me a message. Alrighty, have fun.